Hey everyone, and welcome to this explainer. Today, we're diving into the absolute wild ride that is the modern evolution of artificial intelligence. We're going to trace this incredible journey, starting all the way back in the days of science fiction tropes and boundless optimism, straight through to the rigorous, data-driven science that's practically running our world today. So if you've ever wondered how we managed to go from giant, clunky room-sized calculators to having highly intelligent systems sitting right there in our pockets, well, you're definitely in the right place. Let's get started.
But hey, before we jump into the history, I actually want you to pause for a second and challenge your own assumptions. What exactly is artificial intelligence? When you hear those words, do you immediately picture a metal robot trying its hardest to act like a human being? Or is AI something else entirely? Is it maybe just a cold mathematical system designed to solve problems perfectly without caring at all about how a human would do it? Keep that tension in mind because it's absolutely crucial to the path we're about to explore.
Okay, let's dive into this. Here is our roadmap for today. We'll start with defining the goal, move into the golden age of hype, hit the wall of reality, explore the scientific renaissance, and wrap up with the modern era.
Section 1. Defining the goal. What is AI? Before early researchers could actually build anything, they had to figure out what they were even trying to build. And two completely different philosophies popped up. On one hand, you had thinking humanly. This was the early, really human-centered goal of trying to literally copy our thought processes and match human performance. But contrast that with the other approach, acting rationally. This is the modern mathematical paradigm. A rational system doesn't care about human psychology or mimicking us. It literally just cares about doing the right thing and achieving the absolute best outcome based on the information it has.
Way back in 1950, Alan Turing came up with his famous test to essentially define intelligence operationally. But here's the catch. To pass what we call the total Turing test, which actually includes physically interacting with the world, a computer has to master 6 massive disciplines. It needs natural language processing just to communicate, knowledge representation to remember what it hears, automated reasoning to answer questions, and machine learning to adapt. And then, for the physical world, it needs computer vision to see and robotics to move. Basically, those 6 disciplines make up the entire field of AI as we know it.
Section 2. The golden age of hype. The birth of AI. All right, let's travel back to the 1950s. Computers were incredibly primitive, but man, the optimism was just off the charts. Things escalated so quickly. In 1943, McCulloch and Pitts proposed a mathematical model of artificial neurons. Just 7 years after that, in 1950, Alan Turing published his core ideas on machine intelligence. And all this theoretical math quickly snowballed into a famous summer workshop at Dartmouth College in 1956. That is where John McCarthy officially coined the term artificial intelligence. The field was officially born, and let me tell you, the researchers were incredibly confident. Actually, scratch that. They might have been a bit too confident. Get this, just 1 year later in 1957, Herbert Simon confidently announced to the world that there were already machines that, and I quote, think, that learn, and that create. I mean, it's almost comical in hindsight. The whole point here is that the unbelievable hubris of this era was heavily contrasted against the really basic, clunky reality of 1950s technology. They honestly thought they had human intelligence completely figured out. But let's look at what their so-called thinking machines were actually dealing with. Early AI systems for computer vision and problem solving were completely restricted to what researchers called block worlds. Think of them as super simplified, highly controlled toy environments. The programs could, say, figure out how to stack a digital red pyramid on top of a digital blue cube. And researchers genuinely thought that scaling those simple tasks up to the messy real world would just be a piece of cake. Section 3. The Wall of Reality. The AI Winter. Well, all that initial hype eventually slammed right into a brick wall of reality. The main culprit? Something called the combinatorial explosion. See, early AI relied on weak methods, which basically means trying to string together basic reasoning steps to find a solution through simple trial and error. And sure, that works great in a toy block world, but the real world is an enormously complex problem. When they tried to apply these weak methods to reality, the number of possible combinations exploded exponentially. It completely overwhelmed the computers of the time. The money dried up, and AI entered a deep, dark freeze. Section 4. The Scientific Renaissance. The Return of Data. Fast forward to the late 1980s, and AI finally, well, grew up. It stopped relying on isolationism and intuition, and it fully embraced hardcore probability and the scientific method. Instead of just writing a piece of code and vaguely claiming it acted like a human mind, researchers started building on proven mathematical theories. They subjected their hypotheses to strict empirical experiments. And maybe most importantly, they started sharing massive repositories of test data so that other labs could independently replicate the results. AI shifted from this kind of intuitive, handcrafted wizardry into a hard, empirical science. And this renaissance brought a total game changer back into the spotlight: machine learning. This is essentially an agent's ability to adapt to new things, spot hidden patterns, and actually improve its behavior purely from experience. This is the era where neural networks and a technique called backpropagation made a huge comeback. Instead of humans painfully trying to hand-code every single piece of knowledge in the world, which we learned the hard way causes a massive bottleneck, they built systems that could just learn all that knowledge themselves from raw experience. Section 5. The Modern Era. State of the Art. Which brings us to today. We are living in an era defined by the internet, mountains of data, and hyper-optimized systems. And this circles perfectly back to that tension I brought up at the very beginning. The modern era is completely defined by the rational agent, an autonomous entity that perceives its environment, adapts, and acts to achieve the absolute best expected outcome. The AI in your phone or that algorithm recommending your next online purchase, it isn't trying to be your human friend. It is functioning strictly as a rational agent, doing the optimal mathematical thing based purely on probability. So, how did these rational agents get so ridiculously powerful? Well, a massive shift happened right around 2001. We suddenly went from having small, clean test pools to operating at a mind-boggling scale. We're talking trillions of words of text, billions of web images, billions of genomic base pairs. Researchers had this huge realization. The sheer scale of the data had become just as important, if not way more important, than having the perfect algorithm. If you feed enough data into a learning agent, it can solve incredibly complex problems that previously seemed impossible. To put all these abstract concepts into perspective, let's just look at some modern milestones. Back in 2005, a robotic car named Stanley conquered a brutal 132-mile rough desert course. A little while later, Boss was autonomously navigating through actual urban traffic. And today, every single day, search engines and recommender systems effortlessly sift through trillions of data points to bring you exactly what you're looking for in milliseconds. These are prime examples of rational agents absolutely crushing it in high-dimensional, super complex physical and digital worlds. Which leaves us with one final, kind of provocative question to think about. As AI masters these oceans of data and performs feats that honestly feel a little bit like magic, are we actually getting closer to true human-level intelligence? Or have we just become unbelievable masters at building deeply efficient, rational agents? Based on the massive historical shift we've just looked at, moving from trying to mimic human thought to optimizing pure mathematical probability, well, it's a huge question we're all going to have to grapple with in the coming decades. Thank you so much for hanging out with me for this explainer. Keep asking those big questions, and I'll catch you next time.